Hey everybody, this is Mike from the UX+DevSummit, and we're continuing the journey through Alexa skills and discussing Alexa's capabilities and interfaces. These interfaces are contracts or agreements between the systems, and as an Alexa developer, you implement interfaces, and as a device who supports interfacing with Alexa, you support these interfaces by implementing in such a way that Alexa can communicate through that common interface or contract. So let's get started and continue working through our entire list here. As we walk through this set of cooking interfaces, you may want to picture a microwave or even take a look at a microwave. And one of the things you'll notice is there's a number of options or buttons typically that say things like popcorn, frozen dinner, defrost, etc. So you can think about all of these as an example of where you might use a preset controller. So the Alexa.Cooking.PresetController describes the messages used to control cooking appliances that cook with a custom setting. So in this case, many of those options are custom settings. And this interface is typically the one you would use to implement or support that type of interface. Preset cooking relies on a catalog that you, as the manufacturer, provide to Amazon. Those catalogs can vary by brand, and they typically do also by appliance and as well as specific model. And they actually have an email address that you can use to get in touch with those folks at Amazon. So it's listed right here. As far as the discovery methods go, it includes the standard discovery format, the preset controller discovery, and it essentially handles a response which includes a configuration object. The directive that this particular preset controller supports is the cook by preset, which represents a request to start cooking using a preset option offered by the cooking appliance. Some examples, again, looking at your microwave, popcorn, pizza, frozen dinner, and those would be common utterances that you might support. In this specific example, notice that we didn't specify a time or a duration. We didn't specify a power setting. And this is, again, why this would fall into this preset controller, because the assumption is all of that would be automatically handled for you. So it would take into consideration the best time, the best duration, the best power setting. Continuing with the example of the microwave, the next obviously common setting, or the most common usage, is you will typically go to the microwave and you'll specify a specific type of time that you would like to cook something. In this case, the next interface, the time controller, is actually the interface that describes using a cooking appliance that operates on a time-based system with an optional power level as well. So in this case, you have this time controller and it has a response bundle which includes a configuration object. The directive that it uses is cook by time, and it requests to cook the food in the appliance for the specified duration and add an optional power level. So again, with the microwave, we know a specific value, or said differently, microwaving something according to the directions that are printed on it. So on a popcorn bag, it might say to microwave it for 2 minutes at a certain power setting. In this case, all of those type of usage patterns would fall into this type of interface, or this type of scenario where you apply this time controller method. And so the user specifies in this case an exact amount of time that device should actually use to cook the contents of the package or the item itself. Next in the list of interfaces and capabilities is the error response, which is prescribed as a best practice for dealing with error handling. It's an object that is used typically to handle scenarios where things don't work out well. So currently there are a list of published types that Amazon recommends using to indicate the specified type of a failure that happened. And these can help client or consuming applications handle the error gracefully by either recovering from it or reporting the issue back to the user. The error message typically is composed of the type, which is the identifier that is used to determine what type of error has occurred, and then a message which typically informs more of a description about the error, and this is typically used for logging purposes. This is the information that is not typically shared with the customer, but it actually is helpful for troubleshooting and all of those types of things. So as I read through these, think about all the different devices around you, those that have batteries in them, those that don't, those that have a power supply like an electric outlet, all of those types of things. So types of errors here already in operation. So imagine something's already operating and you're trying to execute that again. You could actually handle that. The bridge is unreachable, meaning that you can't even reach that destination or endpoint. The endpoint is busy, it's tied up. That would be an endpoint busy. Let's say something is low on power, again thinking battery, or something that does not have a power supply, you can actually handle that case. If the endpoint is down, let's say for some reason off the network or not accessible for other reasons, then this would be something you could handle. Pre-authorization credentials, let's suppose those expire, in which case we could handle that. Firmware out of date, in the event that maybe there's some type of update that has not occurred, it's not compatible, it's not backwards compatible. Same thing with hardware. Let's say the hardware actually starts to malfunction. All of those types of things you could report back to the consuming application or client. Let's say there's something that's happening internal that you don't want to expose to the client, something that might be proprietary, etc. All of those types of things. You could use that under an internal error handling identifier. Let's say someone is trying to authenticate but doesn't have access, then you have an invalid authorization credentials identifier you can use. Let's say someone is attempting to use a directive that is for some reason maybe no longer supported or is not a valid directive. Let's say there's a typo or it's just simply not there. Invalid directive is what you could use to handle that. Invalid value, let's say we set a temperature that doesn't make sense or something that is out of range. Let's say that we're setting a percentage in brightness or something like that, which is not really humanly possible. Think about a child, saying some crazy stuff to a light. That all of those types of scenarios could definitely happen. Let's say you're trying to access to an endpoint that's no longer available. No such endpoint would handle that. Not supported in current mode. Let's say for some reason a mode supports a number of operations. Think about your speakers, or think about your channels, think about inputs, think about all of those types of scenarios. In the case that you would want to handle that, you could use this directive, this identifier. Let's suppose that something is just not operating at all. Let's say the device itself is completely turned off. This is another thing that could be handled. Let's say again that you're trying to turn a level that's not supported, thinking about a dimmer or something like that, then this would be a case that you could support that. Let's say there's a traditional amount of requests that the device can handle, and let's say that we go well outside that range. You can handle the rate limit exceeded, the temperature value being out of range. You can handle that as well. Let's say we set the temperature to 2 degrees. We accidentally say 2, or the device incorrectly interprets the value we said, and it starts sending a bogus value. All of those types of scenarios you can handle with these different types of identifiers. And lastly, the value out of range, which again falls kind of more of a broad stroke in comparison to like temperature or power level, but kind of that umbrella that will handle all of those scenarios where we have an invalid value that's being specified by the user. For our next set of interfaces, think about a door with a lock on it. Now, this door could be in a room or to a room or maybe to a house. That's kind of the scenario that we're talking about here. So in this context, Alexa actually has the ability to interface with devices that support online capabilities. So let's suppose a doorknob that actually has online capability. So there are 2 directives that you can use to work with. They're pretty intuitive: unlock and lock. And essentially, you can lock an endpoint or a device, or you can unlock a device or an endpoint, either way. So one of the things that you'll note in the documentation as you're looking through it is that you do have to take into consideration the ability of how quickly a hardware device can complete the request. So obviously things that do not require a lot of computation, things that happen rather quickly, good signal, all of those types of things in terms of network bandwidth, all of that stuff, latency, all of those types of things. Consider all of that in terms of how long a request would be complete. So typically, if it can happen within less than 5 seconds, then you can use the response for a fast lock. If it's something that would take longer than that, Amazon provides an object called a deferred response. And as the name kind of suggests, this is a response that does not happen right away, but rather something that would happen, let's say, greater than 5 seconds. So like 8, 10, 15 seconds. I think any longer than that, you probably don't, you need to revisit the solution and think about how you can make it lock faster. But essentially, this is the high-level interface that you can use to actually interface with hardwares that support locking and unlocking. So really cool technology. So that about does it for this time around. We're going to continue to work through our set of interfaces. Keep in mind that the interfaces are always changing, they're always growing. The number of interfaces we've talked about, this is just the surface we're scratching on, as I continue to mention throughout these videos. But again, this is to give you all a very high level of all of the different types of things you can do with Alexa. So again, by now you should be considering, just looking around you, the number of things that you can interface with. You can pretty much, if it has online capability, you could support it. Which is pretty cool because it really does open up a lot of things and opportunities that weren't previously available, which are now becoming readily available. And since Amazon has done a great job in terms of providing these interfaces, abstracting out a lot of the implementation details from us as developers or consumers, we can now interface with this type of device and actually have it work with all of the things around us. So very cool. So yeah, that's pretty much it. Thanks for checking out the video. Hope you enjoyed it. If you like it, subscribe. We're now coming up to almost I think 15 or 20 videos, something like that. I'm gonna keep these going as long as it takes, and really hope that you guys enjoyed it. So thank you very much. Bye.